Think back to your science classes. What do you remember? For me, it was a world of clean answers. Diagrams had perfect labels, formulas gave predictable results, and multiple choice questions always had one right answer. It was a world of facts, not a world of doubt. It took me years, long after I left the classroom, to realize that real science is messy, complex, and full of uncertainty. The version we learn in school often feels way more certain than the real thing ever does. So why is there this huge gap? Why does science education avoid teaching uncertainty, and what does that omission quietly cost us? Let's start with the most practical reason. Facts are just easier to teach and test. You can ask for a definition, an equation, or the outcome of a specific reaction. It's straightforward. But uncertainty? That requires discussion. It means talking about probability, confidence intervals, competing explanations, and evidence that changes over time. Teaching that level of nuance takes a lot more time and skill. In an education system often driven by standardized tests, clarity and simplicity are rewarded because they're easy to measure. Complexity, on the other hand, gets pushed aside. There's also a developmental reason for this. When you're just starting out, you need a solid foundation. You need to learn the basic rules and concepts before you can start questioning them. If a teacher introduces too much ambiguity too early, it can feel like nothing is reliable, which can be confusing and overwhelming for a beginner. So educators often simplify things to build a student's confidence first. They create a stable structure to build upon. The problem is, for many students, the next step, the transition to complexity and nuance, never fully happens. They get the foundation, but they never see the rest of the building. Think about the tools we use in the classroom, like textbooks. Most textbooks are designed to present the final conclusions, the established consensus. They'll tell you what is broadly accepted, but they rarely dive into the ongoing debates or the contested ideas at the frontiers of science. The messy human process of discovery, the arguments, the failed experiments, the slow accumulation of evidence is usually filtered out. What students get is a polished summary of settled knowledge. They see the final destination, but they miss the entire journey it took to get there. And then there's the assessment system itself. Standardized exams and grading rubrics are built around clear, correct answers. How do you grade a student's understanding of uncertainty? Unless they can perfectly spell out every condition. This system naturally encouraged memorization of facts over the critical evaluation of evidence. When the entire educational structure prioritizes clear-cut responses, teaching the gray areas of uncertainty becomes impractical for teachers who are judged by their students' test scores. Beyond the classroom, there's a cultural factor at play. In many societies, we tend to equate certainty with strength and authority. Ambiguity, on the other hand, can be misinterpreted as weakness or a lack of knowledge. There's a fear that if science education highlights its own uncertainties, the public might lose trust in it. To protect the credibility of science, curricula often lean towards presenting information with unwavering confidence. Unchanging answer for everything. So what's the big deal? What's the cost of shielding students from all this uncertainty? Well, it limits the development of critical thinking. Real-world problems from climate change to public health crises rarely have one simple, correct answer. They require us to evaluate conflicting evidence, weigh probabilities, and recognize the limitations of what we know. If science class never gives us a chance to practice these skills, we're left unprepared for the complexity of the real world. We're trained for a quiz show, not for life. True scientific literacy isn't about memorizing facts. It's about being comfortable with ambiguity. It's understanding that scientific knowledge is not set in stone. It evolves. Models are refined, theories are updated, and evidence accumulates gradually over time. When we only learn the polished conclusions, we can feel confused or even betrayed when scientific recommendations change, like we saw during the pandemic. Teaching uncertainty from the start builds intellectual resilience. It prepares students for a world where knowledge is dynamic, not static. Now, this is really important. Teaching uncertainty does not mean teaching that anything goes or that all claims are equally valid. It's not about promoting relativism. It's about explaining the very process science uses to weigh evidence and measure confidence. It is about showing how scientists distinguish between conclusions that are supported by overwhelming evidence and those that are still tentative and being debated. So when we look at it all, it's clear why science education often avoids uncertainty. Facts are easier to test, clarity feels safer for beginners, and our entire system rewards definitive answers. But we need to recognize that uncertainty isn't a flaw in science. It's a fundamental feature. It's the engine of discovery. When students learn how evidence is weighed, how debates are resolved, and how knowledge evolves, they gain a much deeper and more authentic understanding of what science truly is. Avoiding uncertainty might make for a simpler lesson plan, but embracing it is what truly prepares students for the beautiful complexity of real inquiry and the world beyond the classroom. Thanks for watching. If this made you think, consider subscribing for more videos that explore the hidden side of how we learn and think. See you in the next one.